Come back.
Let me arrange someone who can show you the things.
Good morning, ladies and gentlemen, and welcome back to day 2 of the Design Workshop 9.8. To kick off today's technical session, we are honored to have with us Mr. Aravani Srinivasmurthy, co-founder, Medlax Private Limited. Mr. Aravani Srinivasmurthy is a medtech inventor and R&D professional with more than 14 years of experience in robotics, surgical innovations, and neurovascular therapies. He is a passionate inventor, holds more than 35 US granted patents. His inventions encompass a variety of novel concepts around laparoscopic and robotic surgical instruments. He is currently working as human factor specialist at Factor Neurovascular Research and Development. Today he will be sharing his profound knowledge on the topic cognitive augmentation for human enhancement. The session will be followed by Q&A. I encourage you to actively engage during the same. Please join us in welcoming Mr. Aravani Srinivasmurthy with a huge round of applause.
Thank you for the introduction. Thanks so much for Punit sir for giving me the opportunity to be here and then share my experience with you all. So yeah, rather keeping this as a kind of presentation, I would like to keep this as an interactive session. I'm from industry, so I'd like to share my experiences and knowledge that I have observed in various surgical procedures, and then that I would like to give you a food for thought. So this would be an informative session in terms of what you can do going forward in terms of medical device as well as surgical space if you want to innovate something. Okay? So today's the entire topic will be divided into two things. One is basically human factors engineering and its application in medical device design, and application of the same human factors engineering in cognitive load management for the surgeons. So how are we going to manage the amount of cognitive load on surgeons uh, on surgeon's brain during surgery? So yeah, disclaimer. So I work for a company called Striker. So none of the content or none of the information has a relation, or there is no relation between the information to my company. And this is my profile. So the reason that I mentioned it clearly is that I've gone to 100 plus voice of customers, international and in India, and then more than 150 procedures. Like I was part of the operation theater, cath lab or surgical suits, observing the procedures, understanding what surgery is doing, then trying to innovate around it. That's how I was able to I was fortunate to file about 75 invention disclosures, out of which 35 of them, around 35 plus of them got transferred to patents. So yeah, some of them are being used in the product, so they are not just limited to the shelf. So some of them are being used actively in the product, like the robotics. MNC companies that I have worked with. So yeah, the contents are basically you would like to understand the need, what is the need, and then uh, the current approach to deal the need, and then the current solutions in market, and then how are you going to tackle the solutions. So the objective of any surgery or any instrument that you look at, any surgical instruments or could be a medical device, is what? Improving the outcomes of the patient. That's the objective. You want to design something that's to improve the outcomes, right? And then through that theme line, the presentation will run. So in this, I will be sharing my experiences, and you will have an interaction. So you can raise your hand and ask anytime. So don't be worried about it. Again, we'll be also discussing about some concepts for the future. Okay. So factors contribute to the surgical outcomes. So right from the patient till the medication or the discharge, there are set of series of factors that would contribute to the surgical outcomes. And today we'll be talking about surgeons' skills and surgical techniques and tools. How are we going to enhance both the aspects of it, right? So the need. What do you think of this? The moment that you see this, what do you feel? Right? So too much of crowd, right? And what else? Systematic. Yeah, excellent. Complex surgery that takes more time. What can go wrong? Why is it crowded? What are the other distractions like workload? The amount of uh, uh, sound, the noise, and then the light, then distractions of the other medical equipment present here. So imagine that you are being given an opportunity to design one medical equipment that's being used to, let us say, do this purpose here. You only look at that, right? So what about the environment? There are how many equipment are there? So when you're designing the alarm or when you're designing the noise indications that to be given at certain amount of time in the surgery, you only think about that, right? How much decibel that I have to put and what should be the beep and what is the medical device standard talks about it. But what about the other instruments that are available in the surgery? And forget about that. Every surgery needs this equipment, but every surgery has a set of different equipments that are set up together. If you are using this for general surgery, there might be having 10 different equipment, but the same instrument that you are also using for the brain surgery, it might have a different equipment. So if you design the instrument to be able to use for general surgery alone, then you will have a difficulty in using it in the brain. Not you in the sense you are the designer, you are the user, right? So you have to think about the user. And what is the outcome of having a difficulty in usage? If the product that you are making, there are two things. If it is not properly being able to be used by user, delay of the surgery, delay of the procedure, sometimes injury to the patient. So those things are the risks. So when you're designing any instrument, when you're designing any device, you need to consider safety and performance. First thing is safety, which is called risk management, and then performance of the device. So now that you see the trend, right? The trend of the world is too much of information. So you have lots of information that the moment you see any gadget that in your hand, it will give you so much of information, and by having so much of information, you really never know what information to look for, right? Because you've been keep distracted by the series of information that gets into your mind. So gaining attention has become a commodity. So now the tools are there to actually focus your attention on the particular aspect rather than giving information. So some tools are there to give information. Like for example, if you look at Google is there to give information, but search engine has come up, it has evolved to actually focus on the certain aspect of information that is necessary for you. So it is giving you the attention, right? So what is in the entire scenario of the surgery, what is important is the critical step or critical case, right? The entire surgery, you prepare the patient, you prepare the patient, you prepare the surgical suit, or you prepare the operation theater and everything. Then the patient will be brought in, they will start the procedure, the nursing will be ready with the equipment, infrastructure, everything. And then when the surgeon takes off, when the surgeon takes the instrument into his hand and start performing the procedure, let's say he's doing a brain surgery, right? When the moment he reaches to the critical nerve, right, or critical artery, or let us say this time critical, yeah, critical artery. The moment he reaches to the critical state, if he get distracted or if he didn't get enough information, then the surgery is at stake. So how do we assess? Like there is so much information, how are you going to help him focus on that aspect? So this is a neonatal intensive care unit as an example. Right? So when baby cries, how difficult it is for somebody to listen to it, right? So what is monitoring the baby's condition? Just equipment is monitoring, right? But then how are you going to control the amount of information that's coming out of the equipment to make sure that the proper care is given to the baby? Of course, everything is designed, but too much of a design shouldn't become a problem for the user. What is cognitive load? It's very simple. No, the amount of mental effort required to process the information. You are given so much of information and you are asked to come up with a quick step or quick solution. So you need to put a lot of mental efforts to come up with a solution, come up with a sort of process it to come up with some sort of outcome. Right? What's the mistake here? 1, 2, 3, 4, 5, 6, 7, 8. Yeah.
Colors are not uniform. Some is visible, some is not visible.
Very good. Excellent. I asked for the mistake. Very good.
2 is not matching with the background.
I asked for the mistake. Can you find the mistake? To these, right? So where is our focus? You understand? So user interface, the moment we design user interface, there is a high probability that our focus can be lost. Then that can get into the fatal situations. If it is, let us say, video games or if it is mobile phones or anything, that's fine. But if it's in the hospital, that in the surgery, that in the critical step, then it will be a very difficult situation, right? So these kind of things. So impact of medical errors in some cases. There's huge information in the internet, so I don't want to actually put a lot of information here. So if I distract, you can go through it. There are huge number of cases that are failing because of medical errors, medical level related errors, because the user has he misunderstood the content, or he used it in a different way. Basically there is not, we don't call it as user errors, we call it user errors, because we have to design it for the user. So user, we should make it in a way that user cannot make an error, or if it makes an error also it should not be very high risk. So this is an example of the infusion pump. So the start button and on off button. So there is a confusion. So it has created more than 500 reports of death and 56,000 reports of serious injuries because of the sequence of the buttons, right? So then they redesigned it. Can you see what is the concern in this patient monitoring device? Yeah, I think it's a little difficult, so I'll say it's a demo. It's a demo screen. So how when they keep it as a demo screen with that kind of a visibility, how a user knows, right? So it's high probability that he can make a mistake. Well, so I'm talking about so far I was talking about user needs, what are the critical steps and all the stuff, but how to identify the user needs, right? So there is a discipline, or there's a subject for human factors engineering. I'm sure. Think about human factors engineering. So I'm not going to talk about human factors engineering in detail, but I will give a glimpse because I just added it yesterday. Since in medical device industry, the role of human factors engineering is increasing, evolving. Because earlier the more focus was given to first of all having an equipment itself, right? That's a necessity to have an equipment. Now you have the equipment, and now you have to improve it. to make it more usable, from keep it away from the safety issues or risk, at the same time increase its performance. So those things. So human factor engineering is evolving after seeing a lot of pattern issues with respect to use related errors. So human factor engineering is nothing but it's a combination of engineering, psychology and design. So it merged into the vision, hearing, touch, cognitive and memory. So you know this is basically you might see in the text. What is not in this, right? What is not in this, which I have observed, especially in the Indian scenario. In a way, it is great for Indian scenario. Like I've seen the surgeries of Indian surgeons performing. I've seen surgeries of various other country surgeons also performing. So when I say Indian surgeon versus the surgeon from other countries, so let us say if our surgeon he comes to the operation theater, he will have sometimes or most of the times he will be there for a stretch of 3-4 surgeries sometimes. So sometimes I have to go to operation theater in the morning 9 o'clock. I will continue to stay till evening 3 o'clock, then he will finish 2 or 3 surgeries. Whereas in US and other countries that have been, it's like the planned surgery, one surgery per day. The morning it will start at 9 o'clock or 8 o'clock and finish by 11. Right. So the volume of the cases that our people are dealing is amazing. So, and that also brings us an aspect to be focused upon, the stress on the physician. Right? So, for example, one of the procedures I've been there, physician was standing and he was doing the third procedure. And he didn't have a lunch, so his hands were literally shivering. It's a very critical surgery, but he has to do it, right? It's an emergency case, so he needs to treat the patient. So his hands were shivering and he's doing it. So, what is the equipment that is designed to assist for that kind of situations? Right? It is only physician. The beauty is our Indian physicians are top notch in terms of their skill. So, when we design the medical equipment, we look at two things. One is safety and efficiency in terms of performance, safety and performance. Thus, it's the main agenda of building human factor engineering guidelines for the regulators. Regulators means like ISO and all for you, FDA and all are the regulators, but then for you to easily understand, if the device has to come out of the market, then there is a regulatory body. They hold it, they look at the device, is it safe, how they have designed it, and is it safe to be used on the patient, how many clinical trials they have done it. So for them, human factor engineering is a subject. So for them, they need to make sure that you have done enough amount of research on human factor engineering. Like when I'm using this device, the moment I see it is okay. So the left and right and there's top and bottom. So which is there to move the slide? For me, it's okay. But if it is imagine for the patient option mask on off. So if I by mistake switch it on or switch it off, then it will be. So what regulators does is they will make sure that the patients use it or user use it, and then has a safety data attached to it, and then they will release it to the market. So these are regulatory imperatives about human factor engineering. Then these are the new things. So this is the standard of how human factors engineering has to do the research of the user needs and come up with the use specifications and then come up with the need statements and everything. So first of all, determines user need. So who is user? Sometimes you only think about surgeon, but no, the person who is preparing the equipment is also a user, right? So somebody, if they only design this equipment for me to be able to use, then how do they set it up? When they set it up, they don't know. Then they can make a mistake. So I never know how they make a mistake. And then I start using the equipment, and then that can create a risk in the surgery. Okay, and then understand the user environment, right? So I was mentioning about the environment of the use. There is a good example of understand the user environment. So there is a good example I will show you in the following slide. So user interface requirements, right? The moment you are interacting with your screen or instrument or device or the operation theater or anything, what is the interface between user and your product, right? You understand the user interface requirement. It might vary from person to person, right? For example, there is one product that I was working on that was meant for Parkinson's disease patients with have lot of very shivering hands, and they age, especially in countries like European US, where there unfortunately the care system is pretty much depend only on the public health care, not the children, like the children, they don't take care of parents directly. So they have we have made an equipment for them to be able to use their house, right? And then there was an issue with the availability of the button, so it was not available. So we made a design change of the button to a different design. The spring stiffness has increased. So because for us, what is available in the market, somebody has taken it and there is a good amount of inventory available, so we can replace this with the new button. So we replaced it. Then the moment we actually we were able to use it properly, right? So we can use it. But then we actually send it to the studies. Partner disease patients who are aged, having an element of issue with their motor skills, they were not able to use it. So the whole purpose of optimization or getting into new design is repeated. So you have to understand the user and user interface. If we were designing one instrument for the kids of 11 years, but it has to be under supervision of the parent. So then that's okay. And but then the kid is using it. There's high probability that he might drop it off. So if he drops it off, what is the safety, right? Fail safe. If I drop this off, it should fail. Fine. It should not create a risk, or it should not actually create a flame. So fail safe for the equipment that has been used by some set of users. And risk analysis again, and then design the user interface. How you have to design the user interface, and then conduct a kind of a series of formative, summative assessments. Right? Probably you may be going and then validate the product can be used safely and effectively and document it. This is the slide I made for you people. Actually, I added it last time because you might use those if you want to enter into medical device industry. There is this is the approach, right? You take the human fracturing subject to serious. So because industry needs it, not many opportunities are there, but there's a very niche skill set. Okay? So for your purpose, I have added a slide. Not that. So what is missing in this? This is the standard. Right? What is missing is cognitive load and physician strain. User strain, first a physician, but user strain. How much time he is user using this? How much cognitive load? If he is using a mobile application for monitoring the glucose level in the body, right? What are other applications are he using? We were developing a mobile applications for monitoring the drug intake into the body. Then if it has the same screen with respect to some other application that he is using, there's a confusion, right? So on off button will be same place and he uses something else for on switching on something and then switching off something. So those things is a risk. So we have to go deep to that extent. And any persons or anything with that? Are you connected? Is it good? Fine, right? Going well? Okay, so yeah, thank you.
So when you say understand use environment, doesn't it should include that also?
Yeah, it is. It
Not
should.
missing there.
Ah,
Should. Okay.
It should. Technically, yes, it should include. That's why I showed an example. Right? Simulate. We'll go for simulative studies. Right? We simulate the user. Sometimes we go to the use scenarios like to go and sit. We call it fly on the wall. So we don't talk. We don't even mention to the OT staff or anybody that they are from so and so company or we came for this purpose, because then they will get they will be in alert mode. They'll start doing things very accurate. They'll start like examiner in the room, like so we don't get into that kind of scenario. We just come. I want to learn. I want to see. Say, okay, chalo, yeah, why you want to learn? They treat it as very easy, so they will go with their own pace. It is actually good for us to take inputs, right? The whole purpose of the entire exercise is only to get the inputs and improve the device so that it is beneficial to patient. So it should be, but mostly it is not. As I said, in any device design or any surgical procedure, there is structural critical task. If you look at HF human factors engineering guidelines and everything revolves around the critical task. So by what is critical task? By failing at the task or by doing the task in a wrong way, there is a catastrophe. Simple way. So the entire you make the very good, amazingly organized, only less people, don't have equipment, everything. but still you just end up cutting a important battery or not. Whole thing is on, right? That's a critical task. So you have to design things around the critical task, and they should not have any risk, right? This is what exactly I was talking about, right? User environment. This is how simulated user. So we simulate it with mannequins, with simulated sort of rooms, but then actual case is that, right? Because that cannot be simulated. You have to literally take your product into the uh, theater or patient room, keep it there, be there. To do that, you need to have permissions and everything, and it is also expensive effort, and sometimes you might underestimate, sometimes it's not possible also. So in that case, what they do, they simulate it. In the simulated environment, there's a high probability that they miss out some aspects. For example, if you're designing a device to be able to use by a surgeon, you will only use it like yesterday somebody was asking for the virtual reality kit how long, right? 1 hour is what they design. So 1 hour, right? But if you it's not for the surgeon. I'd say the surgeon is in India and he is using the virtual reality kit to perform the surgery, and if he is using from morning 9 o'clock to evening 4 o'clock, you understand, like he don't want to make a mistake, but he will be forced to do something or the other because of his discomfort. So that's the stress, right? So this is actual clinical context, whereas this is how to simulate the industry simulates. So you need to look at the broader perspective of this. So severity, probability, harmful event, the possibility of harmful event, severity, their probability, detectability, duration. So these are all the regulatory imperatives. For you, it might be difficult to understand. So there are a few examples I took up from the literature and some of the data that's available across the different reports. So avoid indirect indications. I do miss if user is stressed. So here it says error. So check IFU. So we'll go and check IFU. They don't check. So instead you make it in a way that caution low flow. And for more information, just press the button. So first of all, if the patient has a if this is meant for the patient with issues with the vision impairability, very difficult for them to figure it out. Then forget about vision impairability. Even for normal people also it is very, because you are not able to focus on one aspect, right? You have 100 things to look at. So now you look at it and you only look at 100. Okay, that's good. Going on. So then look at the example of as it should be. There's a high probability that these two can be flipped, right? They can connect the wrong tubing to the wrong post, right? So you can do the design by this. So what is the issue with this example?
The emergency and emergency SOS or the alarms need to be more easy to access. For example, if anyone's hands cannot reach, like in the second one, hands are easily reachable to those corners. But in the first design, we can't predict, like we can't say whether the hands will reach there or not. For example, if bedridden,
have a chance of mistakenly pressing the button.
Yes, it's the other way. But it's a good point though. However, for emergency, you always have to keep it within the reachable area, but little away. Otherwise, if they press it by mistake, you don't have to press it with your finger. Your one can still press it by mistake, and then that could lead to stoppage of the procedure, or that could create a delay in the treatment. Right. So, a lot of people accidentally stop the machine. User inadvertently strike stop button. That's a then. This is a good example. So what is the improvement? Like what can we do in this? What can we improve in this?
But we can reduce the intensity of blue color so that the warning would be highlighted.
Very good. I just gave an example before. You can refer it.
Night sight is just a vital
Uh,
in a vertical direction. We they are important and they need to be transit back.
So I think the major part is warning alarm 42, but it does not tell what the
Exactly.
problem is.
That's how. See, those things, remaining things can be managed, right? They're visible, they're fine. But air in blood. So the moment you see, first of all, you see that, then you'll be panicked. What's happening? There's a air in the blood, right? So then alarm 42. What is alarm 42? Right, then what do you have to do? What do you have to do? Go to IFU. Go to the department, identify the user manual, take out alarm, understand what is the air in blood means. Understand by the time anything can happen. First of all, will you really be able to identify that there is a user manual there and this? Do you really see that going to happen? So it's like you identify somebody. So yes, you can, but at what cost? So yeah, so these are all the aspects that you have to keep in mind. So if you think of having a simple user interface, right, and if you want to remove the important content, which you might think that it might happen only once in 100 cases, right? Imagine if the one patient in the 100, or let's say one patient in 1 lakh, it is you. So for you, it's important. It's the same way. I mean, no designer or nobody actually makes the machines. The intent of making it failure or the intent of designing it for the catastrophe. However, you have to take care of certain considerations, and nobody knows what. Right? So there are steps, there are process, and you have to actually adhere to the process and regulations. Make sure that you make it right. So design alarm 42 instead warning air in blood troubleshoot. You understand? So the air in blood is also visible, and then there is a troubleshoot. The moment you troubleshoot, it will show you what to be done. Much easier, right? So look at these two screens. Both of them has no difference in terms of their usability aspect. You're not disturbing it by using. However, you're providing extra information in the next. So this is another example where data has caused some deaths patients because these are the kind of clips that you will really get it in off the shelf. Like you buy them in bulk, 1,000, 1 lakh, and then you start putting because it's easy. But you have to make a customized clip, then it is expensive. So what people do is they look at what is available and then they put it. What is supposed to happen is the housing or the tubing has to only go through one of the latch, not the other one. So by looking at this, scrub nurse or OT assistant or anybody can easily figure out that okay, maybe I have to hang it this way and then they press both of them, and then that has caused a issue with respect to the device. So then they corrected it to have only one. So they removed other part of it so that they can't actually lock it. Are you with me? Good? Or any doubts? So when I talk about user environment, right? So sometimes if you design the device to be able to be used in the areas where there is a high humidity, right? And then and it can cause some sort of the temperature is high. Like for example, you are designing equipment that to be able to be shipped to US, but that happens that goes through some African countries. Inside the aircraft carrier, if the machine is there in the humid condition for longer period of time and the temperature is exposed high, can that cause any issue in the circuit? Do you think of that? I mean, you have to think of that. So you only think about user, you think about user environment, You think about user profile, who is user and all. But when you're transporting the instrument from one country to other country, and because of the logistics and all, if the equipment happen to be in a cold country, right? Let us say it is in Greenland or Sweden, Norway. If it is happen to be in the cold country for certain period of time in the warehouse or in the plant, and if it happens to be high humid, low humid, high temperature, low temperature, will that cause any issue in the circuit or the device? Do we really think about it? It happened in a couple of instances. I was designing a robotic system, first company, where we were sending the equipment. If it is a passenger aircraft, fine. But if it's a commercial aircraft, uh, that it's a different challenge. So we need to make sure that those things are also. So we were creating a humidity chamber. We were, the vaporizers, right? We use it for steaming. So we were filling the humidity chamber with steaming vaporizers and creating the vapor, and then we purchased humidity measurement instruments, and then we measure the humidity. With the humidity, we have switched on the device. With the humidity, we have increased the power input power to the device. We have run the device fully, and then after that we have waited for few days. So those are all the extreme conditions we have to think if you want to export it somewhere, or if you have to use it for some altitude, if you have specific temperature, right? Those things you have to. So this they have designed it as per the standard. So this is the standard test: luminance and contrast, optimal character height, and font size. So do you see that there can be an improvement? What can go wrong? Hmm?
Yellow button to press the second off, but on of course.
Plus minus symmetry.
Okay. Are you doing fine with the time? So I'll say SpO2 BPM 9577. What is that? What does it mean? SpO2 BPM. You understand? So now you divided both of them. Very easy for somebody to understand. There's a BPM and then there's a symbol associated with that. So okay, this is big for SpO2. So there is also an indicator showing how much is the kind of SpO2 level. So user interface is fine, but then the content that is coming out, the monitor, why do you have to have such a big name on top? So you can have it. Doesn't really matter even if you see the monitor or not. Most important parameter is SpO2. See definition. You understand? But this is designed as per the guidelines. Just guidelines. They have met the guidelines, but this high probability that they can create an error. Okay, so now the second aspect is augmented surgery. How are we helping surgeons in terms of augmentation, in terms of improving the way that the surgeons are performing surgery? How are we doing that right now? What are the trends, and what can be improved in that aspect? So, as I told, these are two topics that that I have tried to fuse together. Because one is about the human factor level design. Because I came to know that it's a lot of interdisciplinary students are like computer science, smart manufacturing, and design. Those different streams are sitting here. So you will have probably will have an opportunity to design. If you get into an opportunity to design any user interface of medical evidence, or you happen to develop some applications, for you at least to give an understanding of how medical evidence has to be designed. So I thought to add some slides. So that's why I added some slides. Then how are we going to? How is the trend in the augmentation of search? Like how is the trend right now in surgical enhancements. Yeah, please.
Right, as of now, we have medical things, right? So, for example, let us say laparoscopy, neurovascular surgery. So, like this, we have many kind of medical trends where we already know the process, how to do the surgery as a human. So, this data is being fed into the computers. There are two kinds of surgeries. One, for example, for the brain, which we can see with our own eyes, the computer can see. One is inside the part. So when we the cameras which you have shown, of course, when we place them inside. So this augmented reality, what it does is it inspects the things that are being done there. जो हमारा the things which we cannot see with our own naked eyes, it will be seeing it and it will be showing that here there might be some blood clot, or here you need to cut with this much of precision, वगैरह thing. And the next enhancement says without any kind of human intervention, this augmented reality can be completely shifted to robots and they can do the same kind of surgery. Where as of now in India, this thing is not being happened in that way. Humans are also doing the work with robots. Completely transferring it to the robots with the help of augmented reality is possible in the future. So that is the major thing.
What is it, you want to ask a question or you want to say something? So it's not possible to have a robot without the human interface. There are, if you look at now all the private hospitals, publicity, everybody is showcasing some of the other robot.
So are you, I'm sorry, are you like in this into like telling, assisting surgeons in
Yes.
Improving their
Yes, surgical. Yeah. So now in the surgical theater, you have the surgeon performing the surgery. You have the device. So if you look at it's a whole context of the surgery, right? So you have the devices that are aiding the surgeon, and you have the surgeon performing the surgery. Now you are taking care of the devices that are around the surgery, right? Be it the surgical knife, be it the surgical cutter or stapler, cartilage instrument, or anything. You're taking care of the instrument that will aid the surgeon in the right information. But now you are helping the surgeon itself. How are you going to do? So again, so in this, as we said, experience and the whole series of events, series of activities to treat the patient, we are focusing on surgeon qualification skills and techniques and tools. So in this, especially when surgeon is performing the surgery, holding the instrument and performing the surgery, what are the cognitive loads that influence surgery? Right? Those things are decision-making ability, right? When you have, let us say, when the surgeon is looking at the 2 or 3 screens with a laparoscopy in hand, and he is looking at the screen, and he is seeing that laparoscopy camera. If you see some videos, it will be very difficult because you imagine yourself in a glass stand trying to go around the room, right? For you to identify that particular spot, fix the spot, go to that spot, perform the procedure accurately, it's not that easy. And also 1:1 ratio of your force transmission, right? So if I ask you to stitch a cloth with a needle, you might practice for some time. But then if I give you some sort of an equipment or instrument, and ask you to use it to suture something, and you need a lot of dexterity, like you need to have a lot of experience to do that, right? And then if I ask you to actually go to a small sort of a trocar or a hole, and then get into the bloated abdomen of the patient, and then reach to that particular area where area of interest, there's a lot of muscles around it, a lot of fat around it, a lot of vital organs around it, and then go to the particular spot. We call it as dissection. They remove all unnecessary things from it. They go keep dissecting it and going there, and then particular specific organ they will target it. So that needs lots of focus, right? And then if he's doing the same surgery, similar surgery in a day for 2 or 3 times, then your skill level will improve. But if you keep changing from one organ to the other organ, one to the other organ, technique might be same, but he will have a stress, right? So precision at the key steps. As I said, our Indian surgeons are very good in terms of their precision, because you do 10 procedures in a day, you'll be used to it. So, and then if you look at the surgeons who are having less amount of volume of the cases, they will have to practice. Like you practice you gain. And then surgical volume and other things are contributing factors, but cognitive load is mostly on decision making ability, decision taking step, and emotional psychological factors. Those things comes from equipment, infrastructure around you, sound, volume, sound, noise, and then number of screens around you. So like for example, one of the surgery where I was present, uh, the surgeon came from one operation theater to other operation. In the operation theater, it's supposed to be a bright, because he don't see the screen. He will only see the procedure. So it's supposed to be a bright operation. The next one he moved in, he has to see the sort of image, basically for CT image kind of thing, or that is different terminology. So for them to be able to see that particular anatomical position clearly, he has to have that kind of light switched off. So only for the surgical space he would of course switch on the light, but then the remaining area has to be literally dark. So but if he is constantly moving from one place to other place this way, right? So those things are causing him stress, and then you need to understand how his behavior is changing from procedure to procedure, how his patterns are changing, right? So that is a good study. Right? You have to understand a surgeon's behavior. I think that's just coming up. A few years back, there were companies doing the research of behavioral aspect of surgeon during the procedure, and then there are tools. Right? So literature says stress surgeons more likely to make mistakes. There are numbers and everything. And then now, yes,
Like I experienced a case where there was a really experienced surgeon who had been in the industry for a long time and was doing orthopedic surgery. But the hospital was forcing him to operate using robots, and they weren't they weren't interested in doing it because of the learning curve. So does the learning curve also affect the cognitive load?
so very good point. Actually, I missed it. So it would come in the next slides. But then, yeah, that's a very fantastic point. So actually, my opinion, uh, surgeons or any doctor, the opinion of them is divided. Like for example, if you been asked to if you learned a way to perform the procedure and you excel in it, right? And suddenly bring up something else to you and ask you to do it. Basically, I'm kind of challenging your ability, right? So in a way, I have to assist you. It should be an assistive way, and of course, it is challenging their ability to perform the procedure. Right? So of course, at the end of the day, these are all the tools. It has to be used by a surgeon. And even though he says this organ is this, that organ is that, he has to go and cut the organ and then he dissect it and he needs to shape it. The thing is, the learning curve uh, uh, for any physician or any surgeon to make the learning curve smooth or quick. Now we are coming with the tools, right? The companies are coming up with the tools to make it quick. For example, if it is a robot, then there are simulated environments of robot. You don't have to really buy a robot to use. There are workshops that companies are providing. There are simulators. Basically, you start feeling like which way simulators to use the robot. You feel kind of using the robot. So yeah, it's a kind of adaptation curve you call surgeon's adaptation curve. So that varies from again country to country. For example, one case I'll tell. So in India, as I said, the good thing in India is, for example, if a colorectal surgeon is performing a colorectal surgery. If it involves the usage of let us say mesh or that's supposed to be done by a hernia surgeon. Conductive surgeons will always have the skill to do it. They will do it. So whereas in other case scenarios, they need to have the learning curve, they need to have the approval, they need to have the protocol, they need to have 2-3 surgeons present. So to do the procedure. So the thing is, in Indian context, the learning curve is very quick. So our people will literally learn it, but the resistance is there. But once you pass the resistance barrier, they will learn it. Whereas in Western countries, they will take it up. They'll take it up, and but the learning curve is slow. Ours is you have the resistance and suddenly they learn. There is a slow progression. So I just told you about another example. So it brought me to another. Yeah. So look at the physician's or surgeon's condition. In the surgery, if he's using the, if he's performing the surgery, mostly let us say it's a medical hospital, it's a medical college kind of setting, right? So typically medical colleges are connected with hospitals, right? They have hospital and then they medical. So I've gone to some of the colleges where around 12 to 15 PG students are standing around the top performing an exam. If you are attending an exam, if a professor comes and stand next to you, then you will never be able to make, you will never be able to comfortably write. But look at his conditions. His reputation is at kind of a stake. So he has to perform it in the right way. That's a load, right? Psychologically, that's a load for him. There are medical students around him. There are other colleagues of anesthesia, general surgery around him. There will be staff, nursing staff, technicians, of course, patients are just waiting outside. But then the most important thing is those who are inside observing what surgeon is doing. Like they all are looking at the surgeon's hands and everything, right? So get how to do it very. Any surgeon they do it very great. So yeah. So that's the psychological stress. So I was talking about psychological factor. That's one of the psychological. So the number of, so whereas that's why in other places, in some places in India also, it's not allowed. Not everybody is allowed to get into. Only few of them are allowed, and it's very confidential. What happens inside? How he has done it and all. Very confidential. There are some ethical guidelines around it. Even for example, if you happen to do a clinical study of getting some data to understand the patient parameters. In India, it is now they are constantly bringing up good amount of regulations in maintaining the privacy of the patient. Right? Since standards now are changing. Even the medical level design standards. Earlier, in the last few years, we were just following what Europe's. We have one sort of have easy access. But now our government is emphasizing why not we? Like when Europe and US are having their own boards to control the regulations, we also want to do it. Right? We are not we are not very difficult. So we are also coming up with lot of regulations. So of course, the patient information, I will say, it comes around the ethical concerns of the institutes. So that's why in some institutes, not everybody is allowed to get in, but it also happens that in PG colleges, there are a lot of crowd around him that would cause the psychological stress to the doctor. So as I said, literature survey says a lot of issues with respect to stress physician, and then regulatory imperative says recent regulatory imperatives are also mentioned. Fatigue, physical, psychological. Avoiding the monitoring that requires lengthy concentration. So length, psychological stress, and then physical stress. Those things are also mentioned in the regulatory context. So by doing that, you need to make sure that your device is been designed to fit for the regulators, right? As I said, critical task I told you. So there is a standard notation called hazard, harm, and hazardous situation in medical level design. So hazard is potential source of harm. When you're designing the instruments, surgical instruments or surgical situation, what can create a hazard? Noise, destructive noise, visibility issue, psychological pressure, skill, experience, availability of. Harm is what can be the harm? Delay of procedure, blood loss, or failure of the procedure, misuse of instruments, high risk to the patient. And these are the top five surgical errors across the board. So leaving the foreign objects behind. So that's the first. So mostly gauze piece, which actually not many people aware of. Because when they perform the procedure, there is a blood loss, right? And some of the GI procedures or gynae procedures, there is a blood loss. So immediately they have to stop the blood loss by holding a gauze piece and then make it in a bundle and then put it on the spot and then pressurize it. So the blood loss will be there. But by the time the blood loss stops, gauze piece turns into pretty red color like an organ. So it appears like a normal organ. So again, the more focus is given to the critical task, right? You have to stop the blood loss and find the next instrument, call somebody, call anesthesia, people understand the vital parameters. The gauze piece is gone, etc. So performing the wrong procedure, wrong side of surgery also sometimes happen. Anesthesia mistakes and nerve damage. Nerve damage. Again, they're performing brain surgery. There's a high problem that the nerve can be damaged and nobody knows until the patient. So, why do these happen? So, sometimes it's not because of adequate planning before the procedure. The surgeon and his team must be thoroughly prepared for the surgery, including possible complications. So, what happens? What happens? There is immediate error happens in the procedure. Right? They can't actually go to other department, ask somebody to come and help rescue. What can go wrong if you plan it in advance? And so basically, those things, how do you bring the technology into it? The first concept of leaving foreign objects behind. So my company Striker has come up with a product where the gauze piece were given RFID. So we have, let us say, 15, 20 of we call that as Sajipam. So we have, let's say, the bundles of the 15, 20 gauze pieces. Each gauze piece has given RFID. So there is an instrument. So there is a kind of a box. So you take the gauze piece, and then while you take out from the instrument, it will be automatically scanned. You use it in the body, and then if you don't put it back, it will tell you how many have you taken, how many have you put it back. So you have to put it back, otherwise it will be giving alarm. So there is somewhere the gauze piece is missing. So until they actually find that and then put it back, they will not be able to. They will not actually close the patient. So that way, the risk is taken care. So again, this is again a way of helping the surgeon in avoiding the errors, improving his ability to perform better, and also the use. So reduce or eliminate the risk. Augmented surgery, but the purpose of augmented surgery is basically reduce or eliminate the dependency on precision motor skills and movements special orthomic needs. And these things are a bit talking in examples. Identify the critical task in surgery, procedure, studies, surgery, behavior. So, for example, if you are looking a way to improve the procedure, right? Like if it is the brain surgery, the entire surgery, the critical task is to go to that particular point in the brain, and then if it is ablation, like there's a cancer cell or any sort of unwanted tissue in that you have ablate, then you have to go there and ablate, and that ablation is a critical step, right? By doing the ablation, if you are spoiling or if you are actually trying to risk another organ around it, then you need to think of it. So, how do you use the technology in that particular aspect? And identify the critical task in surgery, procedure, study the surgeon's behavior. So, the moment the surgeon comes to the operation theater and he starts using the instrument, for how he is behaving. Like is he tense? Is he stressed? Is he not sure of what to do? Which equipment he is picking up? For example, if he takes up an equipment, it has to be in a series of actions, right? He takes up first equipment to actually open it up. Sometimes simple surgeries are like preparation is done by the assistants, right? If there is a change of assistant, then somebody else comes. Then if he takes up the equipment and then he gives the equipment that is not in the sequence to him, if he starts using it and then he finds out, then he has to go back. Right? So it's a delay. And plot the patterns of stress failures in which surgeries has he failed. So there should be a way to measure, monitor, and give the data, right? And then how to monitor and what to monitor. Why is it too crowded? So surgery strategies to enhance the usability and reduce the probability. Simulators are there right now that we are seeing. simulators are helping in terms of visualization and training, improving the training curve, adaptation curve for the advanced techniques. Protocols and all are pretty standard. And then interface designs that we spoke about. That's why I brought that interface user interface design in the first piece of the presentation. And then instrument design. So indeed, the environmental optimization is also there, which we also have to consider. And then, so there are currently, so okay, yeah. So far we spoke about operation theater, right? In the operation theater, you have the patient, you have the equipment around him, you have the surgeon, equipment is assisting the surgeon, right? And then device, right? I just mentioned about previously, the previous slide. Interface design and then instrument design. We spoke about both of them, right? Then we spoke about psychological factors associated with it, right? And then we spoke about cognitive load. So that's a continuous topic. So now, how do we improve the usability?
You have talked about these concepts and gave one example where using RFID, you were able to help doctor, assist doctor.
I just
Can
explained.
Can you give some more examples from your company where, I mean, before your company's product, it was like this, and that helped further the doctor, because I was more interested in looking for some concrete example.
Yeah.
If you have some, that would be great.
Yeah. So yeah. So one example is, have you heard of biopsy?
Yes.
Biopsy, right? So biopsy is if a patient is suspected to have some sort of a lesion inside the body, could be malignant, could be benign, like cancers or non-cancers. Right? Let us imagine the patient body this way. If it is in the lung, right? They suspect it as could be a lung cancer. If that the tissue is present in the lung cancer, then the patient will be sent to the diagnostic center. So the user has to, not user, so the doctor, radiologist has to puncture the body using a needle. Let us say the patient, you imagine the patient body this, and this is this corner is the targeted site, right? And I need to go from here without my vision, right? I'm puncturing this. So what I do, I measure the image, I take an X-ray of this whole thing, I measure the distance from here to here. Let's say if it is 10 centimeters, I take up the biopsy needle, I measure the length of the needle 10 centimeters. Okay, I will say, okay, I'll take up the X-ray, I'll say, okay, this is the rib cage here. Okay, I won't go to the rib cage, I go to the next to the rib cage, so it could be 11 centimeters. So approximately I will take it to this way. But it's a 3D space. The needle need not to go this way. The needle can also go this way. Right? You imagine let us say pumpkin or watermelon, and if you want to go to the seed, you take the X-ray. But if you want to pierce the needle through the pumpkin, and the inside the pressure of the tissue can still deviate your path from the actual plant path. Right. So what happens? There are two things: multiple punctures. Right. He takes the scan, identifies that, oh no, it is the tissue is here and it is here. Then he takes it up and then he changes the angle, takes it forward, takes another puncture. Right? If not, it goes. The problem is it's not about multiple punctures. The problem is feeding it into a wrong place. Imagine if you have taken a longer needle and if you pass the needle through the tumor and by mistake if you advance it further, right? It passes to the tumor and then takes the tumor piece and takes it to the deeper tissue, and you never really realize, right? And then you come back and then you take it and then come out. But actually, what happens is you start giving the radiation and chemo here, and then but actually there is a seed, there is metastasis, right? So my first company where we have made a robotic position system for biopsy. So I was the first slide I had that as the key designer for that, like. I was showing to Harikrishna also. If you look at the open healthcare, you can search. The images of that are from my CAD system. So I designed those entire the CAD system, everything. I fabricated the instrument, I fabricated the equipment, took to the clinical trials, everything. So the summary is, we have made a device in a way that you take the targeted point and you take the entry point in the 3D space, okay, and then you give the machine to perform. So it will go. It's a robotic system. It will align itself to a situation where if you advance the needle through that particular end effector, it would not go wrong. It would just reach to the point of the interest, like 3 mm, right? So these are technologies that I have developed with my hands. Right? I've seen the change of the behavior of the surgeons with my hands in the MRI cables, CT cables. So this is a good example. And also,
So how does that your robot understands that this is the right amount, where this is exactly the place when it
so
is
there is a so imagine is a CT. CT sends the images to the
yes.
CT console. Echo images.
It's a 3D reconstruction.
Yeah, reconstruction. Right? So it identifies this, and then that is connected to the robot. These positioning systems will have a connect with respect to DICOM. Okay, and then it is connected to the CT. So it has a reference with respect to CT. How much distance from the gantry? How much distance the
So you
bed?
will first do 3D reconstruction and then you will.
Yeah, it will happen automatically. It's instantaneous.
There are tools.
Yeah, it is instantaneous procedure. So basically, what happens is it will reduce the amount of radiation on the patient body. It will reduce the number of punctures, right? And mostly in one shot, you will reach the target, and then you will take the laser. So that's a real time example. And then few tools that we have designed, for example, if you imagine the colon and then the rectum, right? Rectum is the lower intestines, large intestines, the bottommost part, where there is a high probability of colorectal cancer. So the standard care is basically dissect it and then. So there are we have done some research in days back in organization where how do we use the instruments to do the transanal go through anal canal and then perform the procedure to remove the tumor. So those are the advanced. But the one that is that I mentioned you about the biopsy is the one that I have done with my hands with my previous company. And then surgicom is one striker. And of course, lot of other equipment. For example, if you take the scenario of stents and catheters, right? It's a live example of how you're doing. You remove the clot from the brain, and then the patient is active up half an hour. Otherwise, the patient will have difficulty in terms of even speaking. But you bring him to the cath lab, you perform the procedure, remove the clot, and then patient is here. Anything? So as we spoke about interface design, we spoke about instrument design, environmental optimization, and then now identifying what surgeon is doing, right? The monitoring the focus, right? The surgeon, there are some of the tools available. How are you doing the time? So there are some tools, right? They call Toby glass, head tracker, eye tracker instruments. So they were used earlier. Now also they are using for commercial applications. Like if, for example, if you go to any of the supermarket, the moment you get into the supermarket, they are doing their studies of what is that